So this is the beginning of Trig chapter 4, graphing trig. So we're going to actually be graphing all 6 of the trig functions. But today what we're going to do is we're going to focus on the graphs of sine and cosine. Now, in order to do that, let's look at their parent functions. So first, the graphs of sine and cosine functions repeat their values every period of 2 pi. Not sure why my pi is so far away. And they're known as periodic functions, right? So again, as my graph goes around, I'm going to deal with it in radians, okay? And I can keep going around, right? And I can get coterminal angles, okay? So that's why they're known as periodic functions, because they have coterminal angles, right? So as like the sine of pi, right, gives you 0, the sine of 3 pi will also give you 0. 3 pi is a coterminal angle. That means that I went around 180 degrees plus the original 360 to end up there. Okay, so that's why they're known as periodic functions. Okay, so all of the graph is going to come from the unit circle. Okay, now I want you to notice that in the unit circle, the sign is all of your y values. Okay, so I'm going to highlight my y values. And notice that some of my y values are decent numbers, right? I have a 1/2, a 0, a 1, but some of them are not, right? So I don't necessarily want to use every single number that I'm highlighting. I want to focus on specifics. So the ones that we're actually going to focus on are our quadrantal angles. We're going to focus on the 0. We're going to focus on the pi over 2. We're going to focus on the pi. We're going to focus on the 3 pi over 2. And then the one that's not on my unit circle, but because our graph has a period of 2 pi, we know that 360 degrees is the same thing as 2 pi. So our graph is going to start and stop. Okay. So what does that kind of look like? Okay. So if I made a table, so let's just make a quick little table, right? X's and Y's. So again, my Y is my sine of X. And so if I plugged in 0, really what this is saying is what is the sine of 0 radians, which just gives me 0. Now again, I can plug in the pi over 6, the pi over 4, the pi over 3, but I don't necessarily want to. The 1/2 is going to give me a decent number. It's going to be 0.5, right? But the rest of them are irrational numbers. This is roughly about 0.707, right? And which is not going to be a good number to plot, right? And root 3 over 2 is roughly 0.866. So why am I going to plot decimals that might not necessarily be easy to plot when I can focus on integers? So again, I'm going to skip the pi over 6, the pi over 4, the pi over 3, and I'm going to jump to pi over 2. And so again, the sine of pi over 2 is purely just 1. Again, I'm going to skip the 2 pi over 3, the 3 pi over 4, the 5 pi over 6, and then I'm going to jump to the pi. So sine of pi is just 0. And I'm going to keep going, right? So I'm going to say 3 pi over 2, and so this will become the sine of 3 pi over 2, which gives me -1. Now notice that I said that it has a period of 2 pi. And a period means length, right? So I want you to remember that. It's how long the graph is. So if my graph starts at 0, I need to end where I started. And that's where I'm going to end at, 2 pi. So the sine of 2 pi gives me 0. So essentially, the points that I'm going to plot, so these are what you're going to plot, right? 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, comma negative 1, and 2 pi. So notice it's 5 points that we are going to plot. So how do we actually plot these points? Okay, so let me kind of create a makeshift graph. And let's make this a little bit thicker. Okay, then same thing, make a y-axis. Looks good. Okay, so that looks like a decent graph. Okay, so I want to space out my intervals. So just like you would be going, but we'd be going along our y-axis, we'd be going by, ones and then twos. They're evenly spaced out, so -1, -2. We want the x-axis to be the same. Now, luckily, pi over 2 is the same thing as 90 degrees. So 0, 90, 180, 270, 360, they're all evenly spaced. So when I make my graph, I can easily just put a pi over 2, and I'm going to eyeball this since this is not graph paper. If you have graph paper, it makes it a little bit easier to be more accurate, so to speak. Okay, so pi over 2 pi, 3 pi over 2, and 2 pi. So now we're going to connect the points together. So we're going to plot our points. So 0, 0 gives me that point. Pi over 2, comma 1, it's right there. Then I go to 0, and then -1, so it's in my graph, and then back to 0. So I get this lovely graph, and I get this up-down motion. So this part from here all the way to here, this is the length. This length is 1 period. Okay, now I can add a second period to this graph. Right? I want you to remember that these numbers on our unit circle are just when you go counterclockwise. What happens if I went backwards? Right? 270 is the same thing as -90 degrees. 180 is the same as -180 degrees. 90 degrees is the same thing as -270, and so forth. Which means that if I actually put -pi over 2, -pi, -3 pi over 2, and then -2 pi, okay, I can create a second period. So again, I start at 0, and if I go to -pi, I'm down here, which is going to give me -1. Back up to pi, or -pi, I should say, so I'd be right there. -3 pi, so that means I went all the way around my circle up to here, so I'd be at 1. And then -2 pi would be right back here. So again, notice, and I'll make this dashed so we can see that it wasn't the original period. So notice from here to here, right, is a second period. So it's just a second graph. And our graph just continues on forever and ever. Okay, so when you're asked to draw one period, we'll draw the one that looks solid. If we're asked to draw 2 periods, right, we would draw the solid and the dashed line. Now you can draw the dashed as, actually I will fill this in and I'll just highlight it. Do that instead. So that way you guys don't think that you have to dash your second drawing. So here's our second period. Right, so second period. Okay, now I could have continued my second period on in this way forever and ever. Again, it doesn't matter which direction you go. Now, the great thing about sine, okay, that might be helpful is that sine is an odd function. It's not too important right now, but it's going to be important in a couple chapters. And all this means is that if you take the sine of a negative value, it is the same thing as saying negative sine of your positive value. Okay, and again, we can take a look at something that is on our board, right? So if I say -3 pi over 2, okay, this should be the same thing as saying negative sine of 3 pi over 2. So let's take sine of 3 pi over 2. So sine of 3 pi over 2, it's right here, is negative 1. So negative and negative turn positive. Okay, so far that makes sense. So I'm going to erase this part right here. So negative 3 pi over 2 means that I went around my circle clockwise, and I ended up at this point right here, right? This line, which means that I'm really at 90 degrees, which means that my y value is really 1. So notice that 1 is equal to 1. Okay, so just because you have negative 3 pi over 2 and a positive 3 pi over 2, you are going to have, it looks like opposite numbers, right? Notice that negative pi over 2 and positive pi over 2, again, opposite values. Again, important to remember, not necessary. Okay, so that's what sine's parent function looks like. Let's take a look at cosine's parent function. So again, here's the same information. These are repeated values. They all come from the unit circle. Again, I'm going to focus purely on the quadrantal angles, right? And so again, what I'm looking for is I'm looking for the 0, pi over 2, the pi, the 3 pi over 2, and the 2 pi. And so again, this will give me the cosine of 0. And again, I'm going to use my graph, but this time I'm focusing on my x values, right? So this will give me a 1, cosine of pi over 2, that gives me a 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is back to 0. And we always end where we start. So that means that this is going to be 1. Okay. So let me go ahead and actually copy my graph, my previous one, so I don't have to necessarily reinvent the wheel. Okay, so if I want to graph this, notice what one period is going to look like. So again, I'm going to separate this out. So pi over 2, this will just be pi, 3 pi over 2, and 2 pi. Make this 1, I'll make this negative 1, so it's a little bit further spaced out. Okay, so again, I'm going to plot my points. So 0, 1, that's up there. So again, 0, 1. Pi over 2, comma 0, that's right there. So pi over 2, comma 0. You don't need to write down that these are the points that you're plotting if you understand where they're coming from your table. 3 pi over 2, comma 0. It's right there. And then last but not least, 2 pi, comma 1. So right back up there. So again, this one looks a little bit different. Okay, these are not supposed to be sharp turns. Again, your graph goes on. So your graph is, notice that none of these numbers are larger than 1 or smaller than negative 1. So this graph is going to come back down, and it's going to come back down on both sides. So it kind of almost looks like a little birdie, so to speak. So we can actually continue our graph. So again, this is one period. So one period, again, length of your graph. If I wanted a second period, so again, pi over 2, but make it negative, negative pi, negative 3 pi over 2, and again, negative 2 pi. So again, if you use your circle, and I'll highlight my second period, notice where negative pi over 2 ends up being. So negative pi over 2 are right here. So I'm back to 0. Notice the same thing as pi over 2. Negative pi, I'm right here. Oh, notice it's negative 1. So that's the same thing as just a pi. Interesting. If I go to negative 3 pi over 2, I'm right here, 0. Notice it's the same thing as 3 pi over 2. And then if I make my way all the way around back to 0, aka negative 2 pi, I'm at 1. Notice that negative 2 pi and 2 pi are exactly the same again. So again, I will connect these points to the best of my ability. Okay, and then again, I'll highlight this. This is the second period. Bam. All right, so period. So from here to here, it's a second period. Okay. Now, what's interesting of what I was pointing out, we noticed that, the cosine of negative pi and the cosine of regular pi were the same numbers. And that is because cosine is an even function. So basically what this means is that if you have the cosine of a negative value, that is the same thing as just a cosine of a regular value. Again, not something that you necessarily need to memorize right now. And we can take that for anything. So we did a quadrantal angle for the last one, so let's not do a quadrantal angle for this one. So let's go negative 5 pi over 6. Okay, so 5 pi over 6 is right there at 150. So that means if it's a negative 5 pi over 6, I am actually at 210. It should be right here. So if I focus on my x value, I'm at negative 3 pi over 2, and that's the same thing as a regular negative 3 pi over 2. So again, if I wanted to know, these should be exactly the same thing. They're both a negative root 3 over 2. Again, important to memorize down the road. Now, again, these are all your parent functions. What else can we do with our parent functions? Well, we can manipulate our parent functions, and we can manipulate them with 2 letters. Amplitude, oh, take this away, amplitude and period. Okay, so I'm going to first start with amplitude. Now, I'm going to add some letters in to our sine and cosine. Okay, so our amplitude is our A value. That's what our amplitude is. Okay, and you guys have actually already seen your amplitude. Okay, so I want you to remember that you don't need to copy this down off to the side. That if our parent function was y is equal to x squared, right? Our parabola kind of opened upwards. If I had a negative x squared, my parabola opened downwards. And if I had a 3x squared, right, it almost looks like it was kind of being vertically stretched. So it's almost looking like it was kind of a little skinnier. Or if I had, say, a 1/2 x squared, it almost looks like it would be a little wider. So we've already seen that numbers in front of our function change the shape of our graph. That's exactly what the amplitude is doing. Okay, but again, we want to focus on the number as well as the negative value. So what we're going to say is that the amplitude, which if you want to abbreviate to amp as short, is absolute value of A. So again, we only want to focus on the actual positive value. So if the absolute value of A is greater than 1, what you have is you have a vertical stretch. If you remember that, great. If you don't, not a big deal, because we'll see that when we actually graph. If it's between 0 and 1, you have a vertical shrink. So things are going to be condensed. And then if A is negative, graph reflects over x-axis. Okay, and I'm going to show you some stuff on Desmos to kind of help you out with that. Okay, so I do want you guys to start kind of talking about what you think writing the amplitude out, even if the question doesn't kind of necessarily ask for it. Okay, good habit. Your question though should ask for your period. And your period, again, remember, is the length, right? How long is it? So your B value kind of dictates your period. Okay, and so for your period, I would like you, there are 2 things that with the B value are important. The first thing is that your B, we're going to take the absolute value of B again. In this class, our B will always be positive, but in other classes, it could be negative. So your B value actually, instead of a vertical stretch, it does your horizontal. So this time it has a horizontal, and when it's greater than 1, it's a shrinkage. And when it's in between 1 and 0, horizontal stretch. So again, it's making it wider or it's making it skinnier, right? Now, the second most important part is actually talking about your period. Your period length can be found using this formula. 2 pi, because we said everything happens with 2 pi, and then we're going to divide it by this horizontal stretch and shrinkage. So the absolute value of b. And again, this is for sines and cosines. Other graphs have other ways to find your period. And again, remember, period is just the length of your graph. Okay, so I want to show you what this kind of looks like on Desmos with the period and the amplitude. So let me pop that up. Okay, so here is our parent function for sine. So again, I can't write on a website. I wish I could, but you can see my arrow hopefully is at 0, 0, and you can see that it ends at 2 pi, right? And again, notice that it continues, and then 2 pi can start a period, and notice that it kind of ends that up and down motion at 4 pi. So again, I can continue this on forever and ever in either direction, okay? But again, I'm just going to focus on just the first part. So what does my amplitude kind of do? So notice how my parent function for sine changes when I put a 3 in front of it. Notice that it got a little bit taller and a little bit lower, right? So the blue graph, it really stretched it out. It really stretched your relative mins and maxes out, okay? When you put a 1/2, notice that it's going to shrink it, right? So again, the green is in, it looks like it's a little bit closer, almost looks like it's flatlining against your x-axis. And then obviously if we put a negative in front of it, it's going to flip, and putting them together, it kind of looks like pretty DNA, right? But again, we see that at pi over 2, instead of being a positive 1, we see that it's at a negative 1. And then same thing at 3 pi over 2, instead of negative 1, it's a positive 1. Okay, so what about if I put a number with the x? So let's see what happens. Let's just do our cosine. So here's our lovely cosine. Again, notice at 0, our graph is going to start our period, and we're at 1. And notice that we're going to end this up-down motion at 2 pi. Okay, and again, it's at 1. But again, 2 pi to 4 pi, that again is another period. And again, it could go on forever and ever in both directions. Okay, so again, recall the up-down motion. Notice when I put a 2 in here, what's going to happen? It should be a shrinkage, so we should see this up-down motion sooner. It should hit it before the 2 pi. And that's exactly what we see. So we see that it starts still at 0, right? But notice the up-down motion, we see one whole period well before we even get to 2 pi. So we see it at pi, and then we see another up-down motion by the time we get to 2 pi. So it's almost like we put 2 periods in the length of what 1 used to originally be. And then 1/2, this should stretch it out. So instead of getting to 2 pi, we shouldn't see the end of the up-down motion here. So notice again, it starts at 0, 1, and we see that down motion at 2 pi, but we don't see the up motion yet until we get to the 4 pi. So again, it stretches it out. So that's just all that the amplitude and the period is, of how it's really affecting your graph. So let's go ahead and graph 2 examples and see kind of what they look like. So come back here. Okay, so our very first example, let's graph this. So we're going to say y is equal to 2 sine of x, and we're going to graph this over negative 2 pi to 2 pi. Okay, so that's what our directions are going to say. Okay, when I give you this piece of information, this is telling you how long to make your graph, like where to have a start point, where to have your end point. This is your domain. So your graph is going to start at negative 2 pi and end at 2 pi. All right, that's all that means right now. So let's first figure out other pieces of information that go with this graph. Okay, so the first thing that I want to do is, even though it's not asked, I want to find my amplitude. So remember, my amplitude is the absolute value of that coefficient in front of trig. So that'd be 2. So my absolute value of 2 is purely just 2. right? Do you have to actually write the absolute value? No, you could just tell me that it's 2. All right, your period. So your period, notice that again, you want the coefficient that's in front of your x. There is no coefficient that's present. So that means that it's just 2 pi divided by the absolute value of 1, which is purely just 2 pi over 1, aka 2 pi. So what that means is that our period's length is 2 pi, okay? And so I'm going to start it at 0 to 2 pi based on, I'm not moving this graph left and right, and so 0 to 2 pi. So notice that I actually want from negative 2 pi to positive 2 pi. So this part right here is actually telling me that I'm going to have 2 periods. That's all that that's really telling me. And so my 2 periods will be from negative 2 pi to 0 and from 0 to 2 pi. That's all that that's telling me. If I didn't tell you what domain to use and I just said graph 2 periods, you can graph whatever you want. Okay, so I want you to realize that for your parent functions, we focused on these five values. Okay, there's actually a way that we can find those 5 values. Okay, and how we can do that is we can find the intervals, and we can find the distance between the start and the stop of your period. Right? So we kind of set it up in this way. 0 to 2 pi, this is the start of my interval, of my period. This is the end. And now we want to find the terms in between. Okay, so how do we find the terms? What we're going to do is we're going to average these out. Okay, so I'm going to make this my number 1. I'll show you what I'm doing. So for number 1, I'm going to add my first term and my last term together. So I'm going to say 0 plus 2 pi. And since they're 2 numbers, I'm going to divide that number by 2 because I'm finding the average. I'm finding that middle, right? What's the middle between 0 and 2 pi? So 2 pi divided by 2. If you can simplify your fraction, go right ahead and you pi. Okay, and that makes sense because if we had done it between, not that you have to write this down, 360 and 0, what's half of 360? You would have said, hopefully, 180. And so we're just putting it in terms of radians instead of degrees. All right, so now let's think about the next term, right? So I'm going to make this number 2. Put number 2 down here. Again, I'm going to start with I want to find the average, the middle between 0 and pi. And since they're 2 numbers, I'm going to divide that again by 2, and I'm going to get pi over 2. I can't simplify that, so I'll leave that alone. Now, pi over 2, that's the same thing as 90 degrees. Again, what's the middle term between 0 and 180? It's 90. Okay, so once you kind of understand the pattern, you can easily find the third number, right? So I notice that I'm adding by 90 degrees. So this is plus 90. Ooh, hold on. Try to write that a little bit better. This is plus 90. This is plus 90. You know, then this would be plus 90, and then this would be plus 90. So 180 plus 90, this number should be 270. So this value right here will be 3 pi over 2. And how I can double check, again, here's my third number, 0 plus, not 0, fault, pi plus 2 pi divided by 2, again, that gives you that 3 pi over 2. Okay, it's safe to assume we're always going to use radians unless it's told differently to us. All right, so I'm going to take this away. We don't need this part. Okay, so how do I go ahead and I graph it? How do I graph this? Well, the first thing that I want to do is I want to set up a table. Okay, when in doubt, set up a table. All right, and this will be my y value, aka 2 sine of x. 0, pi over 2, my pi, 3 pi over 2, and 2 pi. Okay, so with your table, again, you're going to be plugging in values. I'm going to substitute in for x, so this will become 2 sine of 0. So you want to evaluate first. So sine of 0 is 0, so 2 times 0 is just going to be 0. I'm going to do the same thing for my other numbers. So pi over 2, that's the same thing as 2 times 1, which gives you 2. Sine of pi, that's 0. So again, that gives you 0. This will be 2 sine of 3 pi over 2. So 2 times negative 1 this time, negative 2. And we always start and stop at the same place. So you should get exactly the same answer. Okay. So we graphed, so we have our points. So now it is time to graph. Let's see if I can, oh, perfect. And I'm going to actually make this just a little bit longer on both sides. Okay, perfect. Okay, so let's go ahead and make some intervals. So I'm going to call this pi over 2. This will be pi, 3 pi over 2, and then 2 pi. I'm going to go as high as 2 and as low as negative 2. All right, so let's see what this looks like. Let me use a different color, purple. All right, so I'm going to plot 0, 0. That plot's there. Pi over 2 to 2. I'm back at 0. Then I drop down to negative 2. And I'm right back at 0. All right, so my graph, again, nice smooth curves. Try to work on that as you are graphing. And again, my graph is going to continue on forever, this up-down motion. Now, you might be asking yourself, how am I going to make my second period? Okay, well, you could make a new table if you wanted to. You can plug these values in, right? You're going to start at 0 again. But this time, you're going to go backwards, right? Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay, and as you go backwards, we already know that this is going to give us 0 because my answer is right there. But my negative pi over 2, again, using my unit circle, right, come back over here, I'm going to go in this direction, right? And so it's really the same thing as 3 pi over 2. Again, it's negative 1. Or I can remember that it is an odd function. I can remember that value. So either one, it's up to you. So what's going to happen is this is going to leave me with 2 times negative 1. So this will be negative 2. This will be 2 times 0, which is just 0. 2 times 1, which is 2. And then this will be right back to 0. Again, all of these numbers, they came from my unit circle. It's really understanding that guy. The other thing to kind of keep in mind is that this pattern continues. So if I start at 2 pi, just remember it goes 0, negative 2, 0, 2, 0. So I know that I'm going to go down. I'm not going to go back up. I'm going to go to negative 2. Then I'll go to 0. Then I'll go to 2. And I'll go right back to 0. So my second period should look the same as my first period, right? That, again, up-down motion. So this is one period from right here, and then this would be your second period. And notice that we graphed from negative 2 pi all the way to positive 2 pi. All right, so let's try one more. Let's see what they look like when you change your b value. So let's go with y is equal to the cosine of 2 pi x, okay? So again, let's graph 2 periods. So we'll graph 2 periods. Notice that I'm not telling you what periods to graph. You can graph whatever you want. I'll do it in different directions so you can see some stuff. Okay, so first thing I'm going to do is I'm going to figure out my amplitude. There is no number in front of it, so that means my amplitude is 1. My period is going to be 2 pi divided by 2 over 3, which is the same thing as saying 2 pi times 3 over 2, which is just 3 pi. Okay, so this is why I wanted to kind of walk through how we found our intervals, because notice that 3 pi is going to be a little bit bigger, because again, our numbers are spread out a little bit more. So I'm going to say 0, blank, 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 3 pi. Okay, because again, my period starts at 0 and ends at 3 pi. Okay, so let's see what happens. So 0 and 3 pi, so I'm going to find this first value. So I'm going to add those numbers together, divide by 2. So 0 and 3 pi, that just gives me 3 pi. Divide that by 2, I get 3 pi over 2. Awesome. Let's try the second one. So 0 plus now 3 pi over 2 divided by 2. That'll be 3 pi over 2 times really 1/2, because division's the same as multiplying by the reciprocal. And that'll give me 3 pi over 4. Now, I could add my 3 pi over 2 with 3 pi, but I'm all about finding patterns, okay? So notice what happens when I write them all with the same denominator. So 0 pi over 4, this is just 3 pi over 4. This would become 6 pi over 4, and this would become 12 pi over 4. So notice they all have the same denominators, so let's focus on the numerators. 0 to 3, 3 to 6, 6 to something, something to 12. Notice that they're all being added by the number 3. So 0 plus 3 is 3, 3 plus 3 is 6, 6 plus 3, this will give you 9. So it'll be 9 pi over 4, and 9 plus 3 still gives you 12. So it's just another way that we can find our points. If you don't want to necessarily add the 3 pi over 2 with the 3 pi. Okay, now those numbers, some of them are on our unit circle, 3 pi over 4. But I want you to notice what happens when we plug them in. This is really important. So I'm going to say 0, say 3 pi over 4, 3 pi over 2, 9 pi over 4, and then 3 pi. Okay, so the first one's pretty simple because I just have to multiply it by 0. So it becomes the cosine of 0, which is just 1. Okay, now you might be thinking, oh, 3 pi over 4, that's on our unit circle. It's in the second quadrant. I thought we weren't going to graph anything with a radical in it. And you're still not going to graph anything with a radical in it. So notice what happens. Your 3's are going to cancel away. Your 2, so hold on, your 3 cancels away. And your 2 goes into 4 2 times. So notice that you still get your quadrantal angle as cosine of pi over 2, which is 0. If I say cosine of 2/3 times 3 pi over 2, notice everything cancels away, and you're just left with the cosine of pi, -1. Cosine of 9 pi over 4. Again, you might be thinking, ooh, 9 pi over 4, that's past a rotation. But when I multiply it all out, this would be the same thing as 3 pi over 2, which again gives you 0. Cosine of 2/3 times 3 pi, again the 3's are going to cancel. So this is the same thing as just 2 pi, which is 1. So that's really important. Your x's, when you plug them in to your original equation, you will always get quadrantal angles. If you don't, then you know that these numbers that you found were wrong. Okay, at least for your first period. As you go, your quadrantal angles would be as if they're coterminal angles. Okay, so let's see what this graph would look like. I'm gonna bring it up on top, and I'm actually gonna show the angle in potentially 2 directions. I'm gonna make the x a little bit bigger. Okay, so now what you could do, these are all evenly spaced out. They're all going by 3's. So what we could do is we could just say, okay, that this is going to be the 3 pi over 4. This could be the 6 pi over 4, or aka 3 pi over 2. And then this becomes the 9 pi over 4. And then this becomes the 3 pi, right? Or, right, you can put little tick marks in between. So this, you can go by 1/4. So this could be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4. Again, up to you what you want to do. The red is just there in case you wanted to put those numbers in. All right, we're going to go as high as 1, as low as -1. And this is what your graph is going to look like. So 0, 1, And then this is going to be at 3 pi over 4, 0. We're back down to -1, 0, and 1. Connect your graph. Boop, 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 boop. Okay. So again, this is one period from all the way from here to here. Okay. If I want to create a second period, so I'll do the negative values, because again, this would be 3 away, and this would be 6 away technically. So negative 9 pi over 4, and -3 pi. So again, you're going to see that if you plug these values in, we have to remember that I said cosine was an even function, so it doesn't matter if it's negative, right? It's still going to be the same thing as a positive value. So these guys are going to follow the same pattern. Bam, bam. And it kind of looks like, called it a bird in class. It almost looks like a bird. Okay, if you, so this is again, second period. If you wanted to continue your period on the other side, right, you can, so you can think about it, it's going to start at 3 pi, and then we have to find the next 4. Well, just remember that you were adding by 3, so this was really 12 pi over 4. So if you add 3 more, this would be technically 15 pi over 4, right? Add 3 more. This would become 18 pi over 4, which we could simplify it down to 9 pi over 2. 3 more gives you 21 pi over 4. Add 3 more, I get 24 pi over 4, which is the same thing as 6 pi. But again, notice from here all the way to here, right, is the period of 3 pi. 3 pi plus 3 pi gives you 6 pi. Again, that's your period. So you would make some tick marks along the way, and then again, you can continue down, down, and then up. Boop, 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 boop. Again, your graph continues forever and ever. Okay, so that's graphing with amplitude and your periods. I want you to try the practice problems and the challenge question that is on Google Classroom. If you have any questions or concerns, please do not hesitate to reach out and ask.